Hi everyone. Today I want to talk about adding and subtracting polynomials. So what is a polynomial? Well, it's a really weird phrase that basically means many terms. So the poly part means many and the nomial means terms, right? So we are already really familiar with some polynomials. For example, the first one here with the square, that's a quadratic. The second one here is linear and the third one is a cubic. Now, we can go further with how many terms there are. This is a three-term polynomial that is a quadratic in nature, or it has a second degree. So we would call this first one a second degree three-term polynomial. The second function here we would call a two-term linear polynomial. And then the final one would again be a three-term cubic polynomial. So, yeah. Now, what is this video really? Well, I don't know. It's just cool to say these polynomial things. We're adding and subtracting them, right? And it's actually as simple as combining like terms. There's a little twist to it, but if you can combine like terms, you can add and subtract polynomials. So there is a notation issue that we have to be really aware of. So we're getting into the Algebra 2 piece that function notation really takes on a different look and feel. So function notation, as you may remember, is f of x, g of x, h of x, pretty much anything that we talk about to distinguish a particular function against another one. So for example, in the previous slides, all of these were y equals. Well, that's not good enough, because if they're all y equals, that means they're all the same function. That means they're all the same line because they equal each other, because y equals y. That's why function notation exists. It's to differentiate between a different group of lines or different set of lines or curves on the coordinate plane. Now, here's the notation that I was really talking about being careful of. There's two ways that we can represent adding polynomials. The first way is f of x plus g of x. It seems pretty simple, right? Take the f function and add it to the g function, period. The second way looks a little bit stranger, but it's the same exact thing. It just means take the f function, add it to the g function, because they are both in terms of x. They both say the same thing, and really and truly, what is it saying? Add the polynomials. That's all. Subtraction is exactly the same. For the first one that we see here, f of x minus g of x, meaning I'm going to take the f of x function and then subtract the g of x function. Or, just like our first one with addition, this subtraction one is f minus g, or the function of f minus the function of g in terms of x. They both say the same thing. Remember that when we subtract, though, we have to make sure that we put parentheses around the second or third set so we can distribute the minus sign. Remember that plus signs don't ever distribute. Let's try some examples. So example 1 says, if f of x equals x minus 9, so I'm going to write that a little bit bigger over here. F of x is going to equal x minus 9, and g of x equals x squared minus 2x plus 1. What is f of x plus g of x? All right, so I'm going to be adding these functions together and combining like terms. So let's do exactly what it says. X minus 9 plus x squared minus 2x plus 1. There is no need for parentheses here because I'm adding them. The parentheses would drop down anyway. So let's combine like terms. I've got an x and a negative 2x. Well, that's negative 1x or just negative x. I've got a negative 9 and a positive 1. That's minus 8. And the x squared is the only term that has a square, so I'm going to put x squared here. Now, mathematically, algebraically, we're right. This is clearly correct, but it's in the wrong form. We need to put this into descending exponent order. So that is, it was really hard to get that to spell right. Descending exponent order. Super important. So let's do that. The x squared goes in the front, the negative x comes next, and the minus 8's there. So we've got our final answer, x squared minus x minus 8. So I'm going to go ahead and erase just this part of it again, so we can do number 2. All right, number 2 says, if x, or f of x, equals negative x plus 12, and g of x equals x squared plus x plus 18, what is f of x minus g of x? Okay, so the setup here is going to be a little bit different though, because it's subtraction. And I've got to put whatever g of x is in parentheses by itself so that negative sign can distribute. So let's go ahead and do that. I've got here a negative x plus 12. I could put the parentheses around this if you really wanted to, but the first one, or the first in order, doesn't need it. minus sign, then parentheses, x squared plus x plus 18. This means, or this helps us understand, that that minus sign has got to distribute. And again, like a previous slide, we don't distribute plus signs, we only distribute minus signs. So this is negative x plus 12 minus x squared minus x minus 18. And now we can combine like terms. Want to make sure I have enough space. Negative x minus x. Well, that's negative 2x. And I like to cross out the things after I'm done with them so I don't like duplicate them. Plus 12 minus 18 is minus 6. And I've got a negative x squared. Again, algebraically speaking, we're totally right here. But we're in the wrong order. It needs to be in descending exponent order. So let's go ahead and do that. This is going to turn into x squared, then the negative 2x, and then the minus 6. Final answer. Let's do two more. Okay. Example 3. F of x is x squared minus 8x. G of x is x squared plus 14x. What is f plus g of x? Now, it's the same exact thing as we talked about, right? And I even kept this part of the screen up, which is extremely obtrusive. So f plus g is the same as take the function of f and the function of g and add them together. So let's go ahead and do that. X squared minus 8x plus x squared plus 14x. All right, I'm just going to add those things together. So x squared and x squared is 2x squared. That means there's two of them now. And negative 8x plus 14x is positive 6x. Final answer, we are already in descending exponent order, so there's no change. Last one, let's simplify. Wait a second now. What happened to, hey, what happened to the function notation, dude? I told you I wanted 4 Oh, wait. Oh, you're right. I'm sorry. I promised him that I'd give him some food the faster we got done. So he just felt like that would be faster for me to do without function notation. Thanks, buddy. Love you. Okay, so what happened here? Well, besides the dog's shenanigans, this is just another way to write adding and subtracting polynomials. We've been doing this for a very long time, actually. We've done this many times. We've done it in Algebra 1. We've done it in combining like terms. You probably did it in some pre-algebra, and you most likely also did it in the beginning of Algebra 2, right? So there's no function notation necessary. It doesn't need function notation, but let's just, all right, I'm going, okay? Jeez. He's like, I want dinner right now. Okay. Dude, it's like, it's not even time for dinner. All right, the minus sign distributes to everything on the right-hand side. I don't know what those arrows are. Those are really weird arrows. Let's rewrite 4x plus 3x squared minus 8 plus 5x minus 2 plus x squared, right? The sign changes everything on the right. So I've got a 4x and a 5x, which is 9x. I've got a 3x squared and a 1x squared, which is 4x squared, and a negative 8 and a negative 2, which is negative 10. We are not in descending exponent order yet, so let's do that. 4x squared plus 9x minus 10. Final answer. Let's finish up. Things to remember about this video. Number 1, know the notation. Function notation can kind of creep out of nowhere if you're not ready for it. Number 2, remember that all we're doing here is combining like terms. That's it. Just because the function notation looks a little strange doesn't mean we are deviating from the fact that we're just combining like terms. And then number 3, when we subtract, be really careful on where to put parentheses. You can put everything in the parentheses if you want, but really we just need that second set or that third set after the minus sign to have parentheses so we can distribute correctly. See you next time.